2022, paper 2, deferred, question 5a. So it says PQRS is a parallelogram as shown in the diagram below, not to scale. So not to scale means you can't measure it. You're going to do calculations. PR and QR intersect at O. Now the minute I hear that, it reminds me of the properties of a parallelogram. So one of the properties are when diagonals in a parallelogram intersect each other, they bisect each other. So in other words, that section there should be the same as that section there. So it asks us to show that the cos of the angle RSQ. Now RSQ is this one. So we're asked to show that that angle is equal to 2/7. Okay. So I mean, my immediate impression is that it's not right angled. There is no right angles here, at least not that we know of, or, you know, even if you suspect, you know, you have to be sure. So there's nothing here to say that there's right angles. So that kind of does away with Pythagoras. It does away with my ratios. So that kind of leads me to think sine rule, cosine rule. And given the fact that obviously it's cos, it leads me to think it's something to do with the cosine rule. Because it says RSQ, I think that's, again, another kind of a hint that RSQ, it's pretty much telling us that we should be using that triangle. Okay, so if we're using the yellow triangle, I know the length of this side is 7. Because the diagonals are bisecting each other, if that's 3.5 there, well, then the whole thing is 7. Now, I'm thinking we've actually got another little fact, and that's that this is in fact isosceles. I wasn't expecting that. So this is an isosceles triangle now. So if I do in fact find, well, I know it's 2/7, but I actually know straight away then what that angle is. And then I can get this angle if I was to require it. So, you know, there's a lot of information there in that space of time. So anyway, let's focus on the current question. So I'm going to do the cosine rule on the yellow triangle. So I start with the side opposite the missing angle. So that's my 7 squared. So I'm starting with that side. I let it equal to the other two sides, 7 squared plus, now this is obviously a 4. Again, property of a parallelogram, opposite sides in a parallelogram are equal. So the right-hand side is 4. Minus twice each of those sides, 7, 4, and then the cos of the angle. So we'll just call it, yeah, we might as well call it what they have, RSQ. Okay, so what I'll do then is I'll isolate that out. So 7 squared minus 7 squared minus 4 squared. Now, just be careful here. In class, I would have talked about sometimes people fall into that trap of they think, oh, I'll just bring this over and it's +2. No, the ones I've moved, we're adding now, they're subtracting. The next thing I'm going to move goes from a job of multiplying the cos to dividing. So please be careful every time you're rearranging cos. Now, I'm not going to do the inverse because the whole point of this is I'm supposed to prove that the cos of the angle is 2/7. So what I want to happen is that this thing here simplifies down to 2/7. So I'm just going to put that into my calculator and hope that indeed it does simplify down. Well, 7 squared minus 7 squared, so they're going to cancel. So I'm basically here with minus 16 on the top line and underneath, so minus 16, underneath I have -2 bracket 7 bracket 4, and I'm getting 2/7, which is exactly what I was hoping for. And we're done. So 2/7 is equal to the cos of the angle RSQ. Okay, now that's the cos of the angle. So the next thing they want us to do is find the distance from P to R. So the distance from P to R. Okay, so where I have the pink highlighter. Now, again, I have the 4 and the 7, you know, here as well, so that's helpful. But what I would really need to progress further is I would really need, I guess, that angle there if I want to use the cosine rule again. So can I go about getting that? Well, I guess I can, because I know, so if I want to actually find the angle, so not just the cos of the angle, but if I want to actually find the angle, I can do, so the angle RSQ is the cos inverse of 2/7. Now, my calculator is in degrees, so I think we're all good there. So my cos inverse of 2/7. Okay, so that's giving me 73.398. So it's 73.4 degrees, really. Now that means, so that's 73.4 degrees, which means because it's an isosceles triangle, this entire angle here is also 73.14 degrees, which means I can calculate the missing one. So I'll just double that and take from 180. So that is, so the little angle here, just where I have the black, that is 33.20 degrees. And the other interesting thing is, because it's a parallelogram, I do in fact have the angle in orange as well, because the angle in orange, remember, they're alternate angles. So I'll just, maybe, what color? I'll use a different color here just to point it out. So do you see the Z shape there? Hopefully you can. So the angle up here is an alternate angle to where I have the orange marking. So that angle is 73.4 degrees. So what we've really learned is the two of them together. So I have 73.4 plus 33.2. So all in all, I can consider that angle there 106.6 degrees. So now I can use my cosine rule again. So this time round, again, I start with the side I'm missing. So in this case, I'm starting with my, I'll call it x squared. So it's really my PR, but I'll just call the whole thing x for the moment. Now, I let that equal to the other two sides, which is 4 squared plus a 7 squared minus twice the 4 and the 7. And then the cos of the angle opposite the missing side. So I've just found out that that's 106.6. So that is 106.6. So degrees. So what I'm going to do is I'm basically going to put all of this into my calculator. So I have 4 squared plus 7 squared minus 2 bracket 4 bracket 7, and then the cos of 106.6. Now that is giving me, so x squared is 80.9985, and there's a bit going on here. I get the square root of that, and it gives me 8.999, which would be 9. You know what I mean? Because it's a kind of an obvious 8.999. It's because of the rounding. So I know that the distance, so P, just to clarify, the distance from P to R is in fact 9 centimeters, and we're done.